Hello, let's go ahead and do 13.3 notes, transformations of functions. So what we're going to do today is we're going to talk about how basic functions, and you should recognize all four of these from their own chapters. We have talked about individually transforming every one of these functions, and they have their own formulas. So when you're transforming or moving around an absolute value function, you know that you have absolute value bars, you move things left or right or up or down. So I've done the same transformations for a linear, absolute value, exponential, and quadratic. But when you do it this way, you have to specifically say what function you're doing. I know this is quadratic because it has a squared term. I know this is absolute value because it has bars. So we're not moving parent functions today, we're moving just basic functions. So in general, if I give you some sort of function, f of x, whether that's already graphed or some function I give you in a function form, you're going to make transformations based on that function. So we know that any number out front is going to stretch or shrink. So if absolute value of a is greater than 1, that's going to stretch that guy. If absolute value of a is less than 1, that's going to shrink. So whatever function I give you, if I put a number out front of the function I gave you, you're either going to stretch that guy or shrink it. Or if a is a negative number, you're going to reflect that over the x-axis. Also, don't forget, anything on the inside is going to move your function left and right, and that's going to move it the opposite of how you expect it to move. So if it says x plus 5, you're actually moving it left 5 units. And then anything on the outside is going to move it up and down, and it's going to move it the way that you do expect it. So plus 5 means take your function up 5 units, down 2 would be a minus 2. So again, instead of actually moving the function around, I'm going to give you some function and have you move that function around. So here's the equation for this function, which is an absolute value function, and it's moved right 2 units, and it's stretched by a factor of 3. So I already have that guy graphed. This is my f function. But given this function here, what if I do this to it? So when I say f of x plus 3, I'm actually saying move this whole function left 3 units. So I went ahead and graphed the original function on the graph so we could easily just move it around. But you literally just move this entire graph left 3 units. I'm just going to take this vertex and go left 1, 2, 3, put a dot. Take this point and go left 1, 2, 3, put a dot. Take this point, go left 1, 2, 3, put a dot. And then I'm going to go ahead and connect those guys. And I have now moved my entire absolute value function left 3 units. This will have its own equation. This is still going to have, if I were to write this, this would be f of x equals, it's still going to have that stretch of 3, but now it's moved left 1 unit, so it's actually x plus 1. But we're not doing that per se, but we have moved the entire function just left 3 units, but we're not actually just writing the new equation on that guy. Okay, next one over here has 2 operations. This minus 1 is going to move it right 1 unit, and this minus 3 is going to move it down 3 units. So I'm literally going to take each dot and move it right 1, down 1, 2, 3, put a dot. Go up here, go right 1, down 1, 2, 3, put a dot. And I'm just picking points that are clearly on the corners. I'm going right 1, down 1, 2, 3. And then my new function looks like this. So what we're trying to get is that I took some original function, moved it right 1, down 3. All right, and this last guy over here, negative f of x, just tells me to reflect that function across the x-axis. So I'm going to take my vertex, flip it over the axis, nothing's going to happen. I'm going to take this point, he's at positive 3. When I flip him over, he's going to be down at negative 3. This point here is at positive 3. When I flip it over, he'll be down at negative 3. Connect those. And I have reflected that function over the x-axis. All right, given this graph, sketch the graph of f of x minus 5. So I have some function, it has its own line equation, we could figure that out, but I'm just saying take the function I gave you and then do this to it. So f of x minus 5 means move my entire function down 5 units, so just go move everything down 5 units. So down 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. Okay? And then I am going to use a ruler for this guy so he's relatively straight. And I have now moved my f of x function down 5 units. All right, for the next one, given the graph, sketch the graph of f of x minus 2 minus 1. So here's our f of x function, and given this function, I'm going to do these operations. Well, minus 2 is the opposite because it's on the inside. It's going to go opposite how I expect. So I'm really going to move my entire function right 2 units. This minus 1 is on the outside, so he's going to behave the same as I expect. So he's going to go down 1 unit. So just take your entire function, move it right 2 and down 1. There actually is an open circle here, so I'm just going to keep that guy. So I'm going to go right 2, down 1, little open circle, and just pick points that make sense. So this little, I'm going to do boom, 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 and boom. So this guy is going to go right 1, 2, down 1. He's going to go right 2, down 1. And then he's going to go right 2 and down 1. Oops. And then when you do your best to connect these guys, I have now moved my entire function right 2 units and down 1 unit. So switching gears here, we're actually going to give you 2 functions already graphed on the same coordinate plane and then ask you how one changed from the other. But the wording makes a difference. So how is f of x transformed from g of x? So g of x is my original function. How did I get from g of x to f of x? So then you just figure out what happened. So it went left 1, 2, and I'm just checking the vertex. That's the easiest point to check. So it went left 1, 2, 3, 4, 5, 6, 7. So it went left 7, and then it went up 1, 2, 3, 4, 5, 6. So it went up 6. So f of x is g of x, but it did stuff. Well, first let's make sure it didn't change the stretch or shrink. We know that quadratics have a 1, 3, 5 pattern, so starting at the vertex goes up 1 over 1, up 1, 2, 3 over 1. So this guy has a normal 1, 3, 5 pattern. Let's check this guy as well. 1, 1, 2, 3. He also has a normal 1, 3, 5 pattern. So this guy did not stretch or shrink, so there's no number to put out front. Also, he didn't get reflected across the x-axis, so there's no negative. So all we did was move it left and right and up and down. Don't forget, when you move things left and right, you do the opposite. So this is going to be x, and because I moved it left 7, I'm actually going to say plus 7. Oh, I'm getting off the screen here. So then I want to go up 6, so I need to put that guy on the outside of the parentheses and just tell me that he went up 6. So to get f of x, I took my original g of x function, moved left 7 units, and up 6 units. That's how I got from here to here. All right, last one on these notes is how is g of x transformed from f of x? So in this case, f of x is my original function, and I want to figure out how I got to g of x. So first things first, I can see that this guy is a reflection automatically. So I know that my equation is going to be g of x equals, well, I automatically flipped it over, so it's going to be a negative. I don't see any stretching or shrinking. We didn't talk about this for this function, but this is actually a sideways quadratic, so it is a 1, 3, 5 pattern, so no stretching or shrinking. So no number outside, so just f of x. Then did it move left or right any? Well, my original point was here. It didn't go left or right any, so there's no left or right number inside, so that just gets stuck. And then once it flipped over, it went down 1, 2, 3 points. So I would just put a minus 3 on the outside. So I went ahead and just found a couple more examples on the internet so we could just write a couple equations. Your homework will be on Delta Math, and it'll be this sort of activity. They give you some sort of graph and they ask you to write an equation. It's multiple choice though, but we got to figure out how to do that. All right, so these are not labeled, but my original function is this red guy here, and then my green function is my new function. So I'm trying to write an equation saying, well, what did I do to my original function to get over here? Well, I'm going to check for stretching and shrinking first. So my original pattern is up 1 over 1 and up 1 over 1. My new pattern is up 1 over 1, up 1 over 1. So no stretching or shrinking. So there's not going to be any number out front here. Also, there's no reflection across the x-axis, so there's no negative sign. All right. On the inside would be moving left and right. So let's see what happened. So my original function, I took it right 1, 2 units, and then I took it down 1 unit. So if I'm going right 2 units, I'm actually going to write on the inside a -2, because it's the opposite how I expect it to be. And then I took my entire function down 1 unit, so on the outside I'm going to write a -1. So I've taken my function, moved it right 2 and down 1. Alright, our next example, we have this one. It actually is labeled, so my blue function actually is f of x. So I'm just going to ask myself, what happened to this function? How did I go from my blue function to my red function? Alright, well, first things first, hopefully you can see that it's just straight up flipped over the x-axis. Let's see if it moved any when it was flipped. Alright, so at this point here, when you flip it over the x-axis, it's at a -2, it's going to make it a +2. This point here is on the axis, flipping it over does nothing, flipping it over does nothing. So this one literally only flipped. I did not move left or right or up or down. If this point had gone up and then moved a little higher, maybe it was moving, but it went from a -2 to a +2, so all it did was flip. All it did was negate those signs. So the only thing that happened on this guy literally is a reflection, so tag on a negative out in front of your f of x, no left and right, so nothing on the inside, and no up or down, so nothing on the outside. Also, I can see there's no stretching or shrinking. It does have that 1, 3, 5 pattern throughout. Okay, last 2 examples and we are done. This one actually does have a labeling of f of x, so I went ahead and started the equation out. So how does this function change into this function? Well, I can see there's no stretching or shrinking. That looks like it's exactly the same. So all I can see is that it literally moved left 1, 2, 3 units. So when you're moving left and right, moving left and right, you just put those things on the inside. Do the opposite of how you expect. So moving left 1, 2, 3 is the same thing as saying +3 on the inside. There is no moving up and down, so this guy is done. All right, and the last one here is, again, just some other function. They gave you a labeling of f of x here, so how does this function change into the one above it? So I can see they have the exact same shapes. There's no stretching or shrinking there. And just pick a point. So this point here, it looks like it goes straight up 2 units. So also it doesn't move left or right. So going up, I'm going to put that on the outside. I'm just going to put a +2 on the outside. Don't forget, things on the inside opposite, things on the outside the same. And then if you put a number out front, that's how you do your reflecting or your stretching or shrinking. Otherwise, looks like you guys are good, and go ahead and do your math homework on Delta Math, and good luck.